Okay, so what are shells, subshells, and orbitals inside an atom? So first of all, let's take a look at a simple atom. So here we have the hydrogen atom. So we know that hydrogen has one electron and one proton. So here is the nucleus of hydrogen, and inside this nucleus is the one proton. Now outside this nucleus is the electron that spins around it. So in this very simple representation, we can see that the electron has an orbit around the nucleus of hydrogen. And that's all hydrogen really is, in a very simplistic way. Now, since it only has this one orbit around the nucleus, and it is the only one, so we call this the first shell, or the number one shell. Again, it is called also then an orbital. And in any atom, there can only be up to 2 electrons per orbital. Again, hydrogen is the smallest atom we have, and it only has 1 electron in the first shell. The shell is an orbital. So now let's take a look at the next largest atom, and that is going to be helium. Helium has two protons, 2 electrons, and 2 neutrons. Okay, so it's a little bit more complicated than hydrogen. But again, helium is the next largest atom that we know. So again, here is the nucleus of helium. And inside the nucleus, it has 2 protons and 2 neutrons. It has its first orbital, and it has 2 electrons on this orbital that spin around the nucleus. Okay, like I said before, the most electrons you can have in a single orbital is 2. So helium now has the maximum amount of electrons in its first orbital. Since it only has the one orbital, we call this number 1. So this is the first shell, and it is an orbital with 2 electrons. So this is the atomic structure of helium. So what about these things called subshells? Well, we will not see different subshells until we hit an atom like boron. So let's take a look at boron. So boron has 5 protons, 5 electrons, and 6 neutrons. Okay, so let's write out or draw out the atomic structure of boron. Again, the nucleus is going to have inside the protons and neutrons. So inside a boron nucleus is going to be 5 protons and 6 neutrons. Now let's take a look now at the electrons. So we have a total of 5 electrons in boron. The first 2 electrons will be orbiting the nucleus as such. Again, these 2 electrons are in the first shell. So this is the first shell. It is an orbital with 2 electrons. Well, we have 3 more electrons to put in, so what do? Well, nature basically makes a larger orbital, a larger sphere that encircles the smaller sphere and encircles the nucleus. And we can go ahead and put 2 electrons here. This is the second shell. So this is the second shell, and it has 2 electrons. Well, we have 5 though. So far we only have 4 electrons here. So what do we do? And what does nature do? The one thing that nature will not do is just make another round orbital. It will not do this to put the last electron. It will not do this. So what does it do? Well, again, we have to remember this is a 3-dimensional structure, right? Atoms are not 2-dimensional. They actually are in 3-dimensional space. So these orbitals are actually, again, in the shape of spheres, not circles, and spheres. So, again, we have to remember that we have an y-axis, this is the x-axis, and this is the z-axis, which is perpendicular to the plane of the screen. Again, this is the y, this is the x, and the z. So what does nature do with the 5th electron? Well, it can do this. Instead of making a larger sphere, it will create a different shape of orbital, the same distance away from the nucleus as the second shell. So it will create what's called a p orbital. The p orbital will look like this. And this is an orbital. It's a different shape, and that's where we will put the 5th electron. So this 5th electron is going to be orbiting in this it looks like basically a figure 8, or again, this is 3-dimensional, so it looks like basically a lobe, like a dumbbell. Again, none of these electrons will be running into each other. So, which is the point. That's what keeps the atom stable. Since this electron is the same equidistance to the nucleus as these electrons, we still call it 2. They are still they're going to be the same distance away from the nucleus. So these are still in the second shell. But since this orbital, the p orbital, is a different shape than the s orbital, which is the sphere, these are now 2 different types of subshells. So this is the p and this is the 2s. These are now subshells in the second shell. So you can have 2, but you can have a subshell of S and a subshell of P. Okay, so here I have redrawn a generic diagram showing the first shell and the second shell of an atom. Okay, so what happens then, we already talked about boron with its 5 electrons. And like I said, in boron, you have 2 electrons here. But now, it has an electron in the p orbital in this here. And if you look at the periodic table, the atom larger than boron is carbon, and it will put another electron here. Again, for every orbital, there are 2 electrons. So what happens with nitrogen? Well, we cannot put an electron in this p orbital anymore. Again, this is the p orbital. P because it's shaped like a lobe. So what does nitrogen do to put its 7th electron? Well, nature says, okay, we can still make another orbital the same equidistance away from the nucleus as the 2 shell. So we'll just put it on the y-axis. So nature will go like this and make another p orbital. Call this the py orbital because it's on the y-axis. and nitrogen is going to put an electron on that orbital. Oxygen will put another electron in the py orbital. And then you get to fluorine. Now it puts the another people on the z-axis. It'll get kind of messy now, but it'll look like this. This is a p orbital along the z-axis. And so fluorine will put its electron here. Let's put it here. And then it'll put another electron. Neon will put an electron on the pz axis. I mean on the pz orbital. So this is your pz orbital. Now, don't forget, as we're getting through the periodic table, as we're adding more electrons, obviously we're adding more protons and more neutrons to the nucleus, because we need more positive charges in the nucleus to balance out all these added electrons that we're adding on the outside. But again, getting back to the question, the difference between shells, subshells, and orbitals, again, every single space that has 2 electrons with it is an orbital, and the shells are basically attributed to how far away they are from the nucleus, and the subshells are talking about the shape of the shells. So a subshell can be S and P, and these are subshells, and the first, and so this is, as we've drawn here, this is the first shell, and this is the second shell. So in the second shell, you can have 2 types of subshells. So the second shell can have 2 types of subshells, but the first shell can only have 1 type of subshell, which is the S. And again, just to reiterate and to say again that every single shell, every single orbital can only have up to 2 electrons.